Good morning, children. Today we will do some problems on fundamental theorem of arithmetic. First, let us see the definition of fundamental theorem of arithmetic. Every composite number can be expressed as a product of its primes. This factorization is unique apart from the order in which they occur. This is fundamental theorem of arithmetic. Every composite number can be expressed as a product of its primes. Now, I am taking one number, composite number, expressing as a product of its primes. Let us see how to write 140 as a product of primes. 140 prime factorization. In lower classes we learned how to find the prime factors of a composite number. 140, I am splitting it into prime numbers. Least prime number is 2, starting from 2. 2 70s 140, again into table. 2 35s are 75, 70. Now 5 7s 35, 7 1s are 7. So 140 can be written as 2 into 2 into 5 into 7. This is equal to 2 square into 5 power 1 into 7 power 1. So 140 is a composite number. It is written as the product of prime numbers. Here 2, 5, 7 are prime numbers. Now, what is the use of this fundamental theorem? Let us see it through examples. We can find HCF and LCM of 2 or more positive integers using this fundamental theorem of arithmetic. Let us find HCF and LCM of 2 numbers using this fundamental theorem of arithmetic. Example, I am taking 26 and 91. Finding HCF and LCM of 26 and 91 using the fundamental theorem of arithmetic. First, we will split 26 and 91 as a product of prime numbers. 26 prime factors. 2 13s, 26, 13 ones are 13. So 26 can be written as 2 into 13. 2 power 1, 13 power 1. In the same way, 91. It is divisible by 7. 13 ones, 13. So 91 can be written as 7 into 13. 7 power 1, 13 power 1. First, let us find HCF. HCF is equal to least power of the product of common factors is called HCF. Here common factors are 13. So here 13 power 1 is there, 13 power 1 is there. So 13 power 1 is the HCF, that is 13 is HCF of 26 and 91. Now we will find LCM. LCM means highest power of the product of common factors and non-common factors. Here common factor is 13 or 13 power 1. Now non-common factors are 2 and 7. So we can write 2 power 1 into 7 power 1. This is equal to 13 into 2 into 7 is 14. Now product of 13 and 14. 14 3s are 42, 14 1s are 14 plus 4, 18. So LCM of 26 and 91 is 181. In this way we can find LCM and HCF of 2 positive integers using the fundamental theorem of arithmetic. In lower classes we learned the relation between LCM and HCF of 2 numbers, that is LCM into HCF is equal to product of the numbers. Product of the numbers. Let us verify for this problem this relationship. Here LCM is 182, HCF is 13, product of the numbers 26 and 91. Let us find the product on both the sides, whether these are equal or not. We will see. 13 2s are 26, 13 8s are 104 plus 2 106, 10 is carried, 13 1s are 13 plus 10 23, 2366. Product of LCM and HCF is 2366. Here we will see the product of 26 and 91. 26 and 91. 1 6 are 6, 1 2 are 2, 9 6 are 54, 9 2 are 18 plus 5 23. 6 6 3 2. So here also we are getting 2366. So LCM into HCF is equal to product of the numbers. This rule is applicable. LCM into HCF is equal to product of the two numbers. We cannot apply this rule for more than two numbers. Let us solve one problem based on this fundamental theorem of arithmetic. Given that HCF of 306 and 657 is 9. Find LCM of 306 and 657. Solution. We know the relationship between LCM and HCF of two numbers. LCM into HCF is equal to product of the numbers. Product of the numbers. Here HCF is given 9. We don't know LCM. So LCM into 9 is equal to, here two numbers are 306 and 657. 306 into 657 implies LCM is equal to 306 into 657 by 9. Let us simplify it. 9 ones 9, 9 sevens are 63, 27, 9 threes are 27. LCM is equal to product of 306 and 73. 306 into 73. 3 6 are 18, 1 is carried, 3 into 0 0 plus 1 1, 3 3 is a 9. Now it is 7, 7 6 are 42, 4 is carried, 7 into 0 0, 0 plus 4 4, 7 3 is a 21, 8 3, 9 plus 4 13, 2 2, so that is equal to 22,338. So LCM of 306 and 657 is 22,338. Now let us solve another problem using this fundamental theorem of arithmetic. Check whether 6 power n can end with the digit 0 for any natural number n. Solution. 6 power n is equal to, I am writing 6 as a product of primes. All of you know 2 into 3 is 6. So it can be written as 2 into 3 whole power n. 6 power n cannot end with the digit 0. So 6 power n cannot end with the digit 0. If a number ends with the digit 0, in its prime factorization there should be 2 and 5. Here in prime factors of 6 power n we have only 2, there is no 5. So it cannot end with the digit 0 for any natural number n. If a number ends with the digit 0 in its prime factorization there should be two and 5, but in 6 power n there is no 5. So, it cannot end with the digit 0 for any natural number n. Now, let us solve one more problem using this fundamental theorem of arithmetic. Explain why 7 into 11 into 13 plus 13 is a composite number. 7 into 11 into 13 plus 13, this is the given number. We have to show that, explain, we have to give the reason, justification why is it a composite number. Now, I am simplifying, we can do it in two methods. Here in first method I am taking 13 common. Here this is one term, this is a second term. In first term and second term 13 is there, so I am taking common. 7 into 11 plus 1. In first two terms 13 is common, so if we take 13 common in the first term, 7 into 11 will be left over. In the second term only 1 will be left over. Now 13 into 7 into 11 is 77 plus 1. This is equal to 13 into 77 plus 1 is 78. 13 into this is 78. I am writing again, it is as product of prime numbers. 13 6 are 78. 13 into 6, again 6 can be written as 2 into 3. So, if we observe 2, 13 and 3, these are all prime numbers. So, product of prime numbers is a composite number. Given number is product of primes. Therefore, it is a composite number. One more method is there. 7 into 11 into 13 plus 13. First we will multiply these 3 with that product, we will add 13. 7 into 13 is 91 into 11 plus 13. 91 into 11. 11 ones 11, 11 nines are 99 plus 1 is 100 plus 13. Now 1001 plus 13, that is equal to 1014. Now 1014, let us split it into prime factors. 2 5s are 10, 0, 2 7s are 14. Again in 3 table, 3 1s are 3, 20 it is, 3 6s are 18, 27 it will become, so 3 9s are 27. In 13th table, 13 13s are 169, 13 ones 13. So, this 1014 can be written as 2 into 3 into 13 into 13, where 2, 3 and 13 are prime numbers. So, these are all prime numbers. Product of primes is a composite number. Given number is product of primes. Therefore, it is a composite number. Composite number. Otherwise, it has more than 2 factors. So, a number which has more than 2 factors is called a composite number.